Let's get started on your notes over simplifying expressions with negative exponents. So the notes you're about to see might look slightly different than what you have on your paper, but just follow along and fill in your notes because all of the content is the same. So let's get started. I like to introduce negative exponents by first just talking about what exponents are. So let's see. If I have 3 raised to the power of 1, what does that give me? 3. What about 3 raised to the power of 2? What is that going to be? 9. What about 3 raised to the power of 3? What is that? 27. What about 3 raised to the power of 4? 81. So what do you notice is happening as this exponent gets bigger and bigger? The value of the number gets bigger very rapidly. Jumps from 3 to 9, then 9 to 27, then 27 to 81. Okay, so let's see. What would happen then if my exponent gets smaller? 3 to the power of 0. What's smaller than 0? Negative numbers. 3 to the power of -1. 3 to the power of -2. If this pattern stays the same, what should happen with these numbers or the values over here? They should get smaller. Well, we know, or you should know by now, that anything raised to the power of 0 is 1. Well, let's see. 3 to the power of -1, that's 1 over 3. 3 to the power of -2, that's 1 over 9. What do you notice is happening? We're taking this up here and we're flipping it. So whereas when we raise a number or a base to a positive exponent, 1, 2, 3, 4, that yields very, very large numbers over here, very large values. When we raise a base to a negative exponent, that yields very small numbers, okay? You can think about it as repeated multiplication and repeated division. So 3 to the power of -3, what do you think that would be? 1 over 27. 3 to the power of -4, you got it, 1 over 81. Okay, let me erase all this and let's get started with our notes. So now you know what it means when I have a negative exponent. So we're actually going to be simplifying expressions with negative exponents. All of your exponent rules that you've already learned still apply. But today, because we're dealing with negative numbers, you have to remember your integer rules. What are my integer rules when I'm multiplying, dividing, adding, and subtracting? So when I have negative exponents, such as a to the power of -m, all I'm going to do is flip the fraction into the reciprocal. That just flips it. So 1 over a to the power of, and then I make that exponent positive. So a lot of students really like to write this over 1. When I take the reciprocal, I flip it, and then this exponent becomes positive. So let's look at some examples. So in these first 2 examples, the first one deals with numbers, the second one deals with variables. 2 to the power of -2, I can write that over 1 if I want. Flip it, make that exponent positive, and then let's simplify it from there. 1 over 2 squared is 1 over 4. So x to the power of -4, what would that be? 1 over x to the power of +4. I can't really see that. Let me rewrite it, +4. Okay, so let's do some more examples. Number 1, x to the power of -8. 1 over x to the power of +8. Number 2, what do you notice it's different? I've got a coefficient out in front. That coefficient is not raised to a negative exponent, so I'm going to leave it there. Anytime you see negative exponents involved, it's a really good idea to make it into a fraction, okay? Anything that has a negative exponent attached to it is going to move, okay? So only the variable with that negative exponent is what's going to move. My 5 stays in the numerator, y goes in the denominator, exponent becomes positive. So what do you notice about number 3? The variable and the negative exponent is in my denominator. If I flip this, what happens to that variable in the exponent? It now goes in my numerator. So that's kind of a generally what you can do. If it's in your numerator and it's negative exponent, move it in your denominator and make it positive. If it's in your denominator, negative exponent, move it in your numerator and make it positive. So I can rewrite this as m squared. Looking over here at number 4, 4 over 3, well, I have a negative exponent attached to that 3 up, or that x up top. That's going to move down low and come positive. I've got a negative exponent attached to that y. That's going to move up top, and it's going to become positive. So look at what's going to happen. We've still got 4 over 3, but y goes up top, positive exponent. X goes down bottom, positive exponent. Do you see how I did that? I just flipped the variables and I made the exponents positive. Okay, so on number 5, I've got a coefficient that's a fraction. All right, so this is really what I like to do with this. 3 over 8. When I've got this fraction like this and all of these variables times x to the power of 9 times y squared times z to the negative 4th, those are all essentially in my numerator. So watch this. If you see anything with a negative exponent, what can you do? Move it in your denominator and make it positive. If it already has a positive exponent, what do you do with that? Leave it there. So let's look at my negative exponents first. I see x to the power of negative 9. I'm going to put that in my denominator, make my exponent positive. I see z to the power of negative 4. I'm going to move that in my denominator and make my exponent positive. Y squared, what happens with that? It stays up top, y squared, okay? So if I wanted to, I could have rewritten this as 3 over 8, x to the power of negative 9, y squared, z to the negative 4th. So then if that helps you to maybe understand, okay, I'm moving only this variable in negative exponent down, only this variable in negative exponent down, you can always rewrite it like that. Okay, let's look at number 6. Ooh, goodness gracious. Okay, now I have a number with a negative exponent, a variable with a negative exponent, a number down here with a negative exponent. Okay, so what happens? Well, I know that 3 to the power of negative 2 is not 9, it's, flip it, 1 over 9. So what I can do is I can take this, 3 squared is 9, but since it's 3 to the power of negative 2, I'm going to put it in my denominator and make it 9. That 2 to the negative second power, because that's a negative exponent, remember I can move it up top. So it applies when your base, that big number, is also a number, not just a variable. So 2 squared, 1 over 2 squared is 1/4. So 1 over 2 to the negative second power is 4 over 1. So I'm going to move that up top, and I'm going to move that 3 to the negative second power down below. Okay, so we attacked our numbers already. Now let's look at the variables and their exponents. That x to the power of negative 9, what's going to happen? It's going to move down low, positive exponent. Let's go to the next letter of the alphabet, y. That's got a negative exponent. What am I going to do with this y? Move it up top and make it positive. And then z to the 8th, what happens with that? It doesn't have a negative exponent, so I'm just going to leave it down here, z to the power of 8. And that's how I simplify that. So in our next section, we're actually going to be using all of our exponent rules that we've learned thus far, the product rule, the power rule, the quotient rule, and some of those might involve negative exponents, so we need to remember our integer rules. So let's look at this first one, number 7. Okay, so the first thing I want to do is I'm going to go ahead and just rewrite these numbers right here, okay? 3 to the power of negative 1, well, what's that going to be? That's going to be 1 over 3. So that 3, I move it to my numerator and my denominator down, and I simplify it. 2 to the negative second power, what happens with that? Well, 2 squared is 4, but it's down below here, and that exponent is negative, so I'm going to move it up top and make it positive. Okay, so now let's look at our variables. So we attacked our or I should say addressed our numbers first. Now let's look at our variables. Okay, so m to the power of, what do I do when I'm dividing and I have the same base? What can I do with my exponents? I can subtract them. What's negative 5 minus 7? It's negative 12. So m to the power of negative 12, n to the power of, what's 5 minus 6, right? Top one minus the bottom one. What's 5 minus 6? Negative 1. Now we're going to multiply this times 3 times m to the power of negative 4, n to the power of 6. And let me rewrite that negative 4 so we make sure we know what number we're looking at. And now we're multiplying. What do I use when I'm multiplying? I use the product rule. So numbers, then variables. The first thing I'm going to do is 4/3 times 3. And what do I get when I multiply 4/3 times 3? I get 4. So 4. And if you struggle with that, plug it into your calculator if you're allowed. And then what do we do with the variables and their exponents? One variable at a time, m to the power of negative 12, m to the power of negative 4. I can add my exponents. So I get negative 16, right? There's that integer rule I'm talking about. Same signs, add and keep. Then n to the power of negative 1, n to the power of 6. When I combine those, I get n to the power of positive 5. Different sign, subtract, take the sign of the larger number, then it'll be exact. So now if I rewrite this using only positive exponents, well, what's that going to look like? Well, you've got a negative exponent, write it as a fraction, take that negative exponent with that variable and move it down. That's the easiest thing to do. So I'm going to get 4 times n to the 5th over m to the power of positive 16, and that's my answer. Okay? So rewrite using only positive exponents. Now when you get in upper level math, a lot of times this is an answer right here. That's okay. Okay, it's really kind of teacher preference. But right now we're just rewriting using only positive exponents. So let's go on to number 8. Now when I'm simplifying these, I want to recall my order of operations, PEMDAS. Okay, I need to simplify exponents before I can do any kind of multiplying and dividing. Okay, so right here, I see there's an exponent right outside the parentheses. I need to apply my power rule and simplify that. But I also see over here, I've got some division. So I'm going to kind of do both of these at the same time. So let's simplify this fraction up front. 2 over 16, that simplifies to 1/8. And then now I'm going to apply my quotient rule. X to the power of 5 minus 8 is negative 3. Apply my quotient rule to the y's. 6 minus 2, what do I get? Y to the 4th. Times, and I'm going to go ahead and simplify this other term over here using the power rule. Numbers, then variables. So 2 to the power of 3. Remember, off to the side, I like to write 2 to the power of 3. What is that? It's 8. We don't do 2 times 3. Okay, it's 2 to the power of 3. Then I can apply my power rule to these variables and their exponents. So if I don't have an exponent there, what could I write there? I can write a 1 times x to the power of, what do I do with those exponents? I multiply them. 1 times 3 is 3. Y to the power of 1 times 3 is 3. And now we're back to, we're multiplying, so what can we use? The product rule. Numbers, then variables. So the first thing I'm going to do is 1/8 times 8, which is 1. And I can write that down, but I don't have to. If you want to, you absolutely can. I don't really like to, so I'm not going to. Then one variable at a time. Okay, if I'm combining negative 3 plus 3, because that's what my product rule tells me I can do, I can add my exponents. Well, I get x to the power of 0. Anything to the power of 0 is what? 1. So that would just be another 1. It would look like this. 1 times 1 times, and then y to the power of 4 plus 3 is 7. So your answer is just y to the power of 7. Okay, let's move on to number 9. This one is a bit of a challenge. So let's get started. Lots of stuff going on with this one. I see a fraction inside our parentheses. We have the same variables on top and bottom, so I'm obviously going to have to simplify using the quotient rule. I've got an exponent right outside my parentheses, so I'm going to have to apply the power rule. Another exponent outside the parentheses, another power rule, and then I've got some multiplication. And then I've got plus a negative, which we like to make is just one big minus, one big negative. Okay, lots going on here. So the first thing I'm going to do, the first thing my order of operations tells me to do is simplify what's inside my parentheses. So let's do that. Numbers, then variables. Let's simplify negative 4 over 6. What does that simplify to? Negative 2/3. Negative 2/3. Then I'm going to apply my quotient rule. Look at the a's. A to the power of 7 over a to the power of 8 is a to the power of 7 minus 8, which is a to the power of negative 1, times b to the power of 6 minus 4 is 2, all raised to the power of negative 2. Now I'm going to just do a little bit at a time. Let's do this next one. 1/2 raised to the power of 1/2 a to the 4th times b, all raised to the power of negative 2. Okay. 1/2 raised to the power of, let's look at our numbers first. 1/2 raised to the power of positive 2 is 1/4. So 1/2 raised to the power of negative 2 is, flip it, I get 4. Okay, so 1/2 raised to the power of negative 2 is 4. Times a to the power of, apply your power rule. 4 times negative 2 is negative 8. B to the power of, can I put a 1 there? Sure. 1 times negative 2 is negative 2. Whew, lots going on, and let's go ahead and simplify this. Plus a negative is the same thing as minus 9, a to the power of negative 6, b to the power of negative 6. Okay, let's do the next step of simplifying. Okay, so now over here, all of this right here is being raised to the power of negative 2. So when I square a fraction, I actually, and I take a it's squared, like it's multiplied by itself. Okay, so negative 2/3 times negative 2/3 is going to be positive 4/9. But since this exponent right here is negative, I'm going to flip that fraction. Okay, that becomes 9 over 4. Okay, that's what happens. So our fractions flip. Okay, you can still square them or raise them to the power of 3 or whatever, but if that exponent's negative, you're going to flip that fraction, right? That's kind of what we did here, okay, with the 1/2. All right, now I'm going to apply my power rule. So let's look at our a's. A to the power of negative 1 times negative 2 is a squared, times b to the power of 2 times negative 2 is negative 4, times 4 times a to the negative 8th, b to the negative 2nd, minus 9, a to the negative 6, b to the negative 6. Now when I'm looking at this and I'm subtracting, I'm thinking I'm probably going to get a term over here with this 9, 4, a squared, b to the negative 4, all that looks like a to the negative 6, b to the negative 6. Let's see. Doesn't always happen, but a lot of times it does. So I'm multiplying these two terms right here. The first thing I need to do is multiply my numbers. 9/4 times 4 is what? 9. Now let's apply my product rule to the variables and their exponents. A's first, one variable at a time. 2 and negative 8, what does that combine to? Negative 6. Now let's look at the b's. Negative 4 and negative 2, negative 6. Minus 9a to the negative 6. And what do you know? We've got like terms over here. So can we combine them if we have like terms? We sure can. This a to the negative 6, b to the negative 6, that is what tells me these are like terms. When I have like terms, I can combine them. How do I combine them? Combine their coefficients. What's 9 minus 9? That goes away. 9a to the negative 6 times b to the negative 6 minus 9a to the negative 6, b to the negative 6. What do I get? I get 0. I get nothing. 0 is your answer. Okay, let's move on to this next one, number 10. Oh gosh, we've got a lot of stuff going on here. I've got an exponent up here, outside of my parentheses. I obviously need to apply that first. Then I've got some division going on here. I'm multiplying by this, but I've got an exponent outside of here. Okay, so when we think about our exponent rules, the first thing I need to do is figure out what the value of this is. What's the value of this? So I need to apply my power rule. Get rid of those parentheses. So let's do that in our numerator up here. 2 to the power of 3. What is that? So we're raising everything to the power of 3. 2 to the power of 3. That's 8. Times x to the power of, what do I do with my exponents? Multiply them. Negative 3 times 3 is negative 9. Y to the power of 4 times 3 is 12. Over 4x cubed y. And I'm going to put a little dot there. So what do I do over here? Again, everything is being raised to the power of 5. So I need to apply my power rule so I can get rid of these parentheses. So the first thing that happens is 2 is getting raised to the power of 5. What do I get? 32. Then I can apply my power rule to these variables and their exponents. So times x to the power of 2 times 5 is 10. Y to the power of negative 2 times 5 is negative 10. Okay, minus 4x to the negative second power y. I wonder if we're going to get any like terms. And I'm going to switch colors here. So now I've got some division right here, I've got some multiplication right here, and then some subtraction. Order of operations tells me I multiply and divide from left to right, whichever comes first. That division is what's coming first. So let's do that. So I'm going to apply my quotient rule. What is 8 divided by 4? It's 2. And then I can apply my quotient rule to the variables and their exponents. So negative 9 minus 3, what is that? Negative 12. Times y to the power of 12 minus, well, what is that? I don't have an exponent there. Well, can I put a 1 there? Sure. Y to the power of 12 minus 1 is y to the power of 11. And I'm just going to rewrite this because we're simplifying one little bit at a time. Okay, I'm just going to change colors here again. So now I've got some multiplication and some subtraction. I need to do my multiplication first because that's what my order of operations tells me to do. What's 2 times 32? Remember, numbers then variables, 64. Then what do I do with my variables and their exponents? Since I'm multiplying, I'm going to apply my product rule. So x to the negative 12th times x to the 10th is x to the negative second power. Y to the power of, what do I do there? 11 and negative 10 is just 1. Okay, you don't necessarily need to write an exponent of 1 there. It's assumed 1 if nothing is there. So minus 4, x to the negative second y. And what do you know? We have like terms here. This x to the negative second y, x to the negative second y, those are like terms. Because I have like terms, I can combine them. If those weren't the same, I wouldn't be able to subtract them. So how do I subtract like terms? Subtract the coefficient. 64 minus 4 is 60. Then last name stays the same. So there's your answer, but I'm requiring you to write it as a positive exponent. So what's that going to look like? 60 times y over x to the power of positive 2. Lots of notes today, and it's obviously getting more and more challenging the more rules we add to the picture. So this is challenging, but I hope these notes were helpful and that you understand negative exponents better.